All right, I hope you are excited to be back with us this year. We're going to learn a lot of math, and we want to start by making sure everybody has the same basic understanding of an essential feature of what our year is, which is understanding what a function is. We will be dealing with a lot of different functions in Algebra 2, and we want to make sure that everybody has a common base. So a function is a relationship that gives exactly one output for every input. And a lot of times we'll think of a function as like a box that when you put something into it, when you put in an input, it tells us what the output is. So in general, we will use x as the variable for our inputs and y as the variable for our outputs. So when you see an x, you can be fairly sure that that's an input. And if you see a y, you can be fairly sure that's an output. The way we read this, you may have noticed there is an f with an x in parentheses. And we read this as not f parentheses x, we read it as f of x. F stands for a function, and we read it as a function of x. So a function of x. We don't have to use the letter f, even though we'll still be talking about functions. We could use g, and then this would be read as g of x. Okay. Each input and output pair is a point. So each input-output pair is a point, and we can write it as x comma y. This means an input comma an output. And functions can be represented in a bunch of different ways. The first way we're going to look at representing functions is with tables. And you may notice that the left side is labeled x and the y side is labeled y. The left side of a table will always be our set of inputs, and the right side of a table will always be our outputs, although we don't have to use x and y. And each pair of points, x and y, is each pair of values is a point. There is the input x and the output y. There's the input 2 and the output 6. And so this function tells us for these 4 values what the outputs are. Now, this is a function that only tells us the outputs for 4 different values. Tables are somewhat limited. They show a few points. And let's talk about how we read these. If we put f in parentheses 1, the way we read this is f of 1. And f of x says is a rule telling you what the output is for each input, and x is the input. In this case, 1 is the input. It's saying when the x value is 1, when the input is 1, we want to know what the output is. And the table tells us when the input is 1, the output is 3. And so what we write is f of 1 equals 3. We can do these for other values as well. I want you to think to yourself, how do we read this? What do we say here? How do we read this out loud? And you should say f of 2. And f of 2 is asking when 2 is the input, what is the output? Go ahead and answer that on your own also. What is f of 2? And we can see here that f of 2 is 6. Try another one on your own. What is f of 100? This is asking when 100 is the input, what is the output? And the output is 300. And let's look at a different one. This now says f of 5. It says when 5 is the input, what is the output? And 5 is not an input listed in this table, and so there is no defined output. We write that their output is undefined. There is no defined output. Now, some of you may be very astute, and you notice that there's a pattern here, which is that the input always gets multiplied by 3 here. 1 times 3 is 3. 2 times 3 is 6. 3 times 3 is 9. 100 times 3 is 300. And so you might think f of 5 could be equal to 15. And that would be true if we had some additional information, like if they told us that the function was f of x equals 3 times x, and these were just some of the values, then f of 5 equals 15 would be correct. But if they don't tell us some additional information and this is the whole function, then you cannot make assumptions about other values, even if it seems like it could follow a pattern. Once they give you other information, like that these are just some of the values, then you can go further. Let's practice this on your own. How do we read this out loud? What is this function? You should have said g of x is how we say it. That's how we speak it. And we want to be able to say, what does this mean? How do you say it out loud? So how do you say this? This is g of 3. And g of 3 is asking the question. I want you guys to say, what question is this asking you? And g of 3 is, of course, asking when the input is 3, what is the output? And so when the input is 3, what is the output? What is g of 3 equal to? And the answer is 1. Go ahead and answer a few more on your own. What is g of 7? And what is g of 5? And we should have gotten that g of 7 was negative 2, and that g of 5 was negative 2 also. It's okay that the same output happened. Remember, the definition of a function was for each input, there is only one output. Well, for this input, there was only one output. For this input, there was only one output. It's okay that that output got repeated. Okay, what is g of 11? Go ahead and answer that on your own. And because there is not a value for an input value of 11 that tells us what the output is, this is undefined. So hopefully we felt comfortable with that. Now here is h of x, but I put a question mark on this. H of x question mark, is this h of x? And there is something you might notice. Go ahead and take a look at this table for a second and see if there's something very noteworthy that you can see. What you should notice is that the input 1 gets repeated. And so this is when we ask the question, h of 1 equals, when x is 1, what is the output? Is it 2 or is it 7? And because we don't know the answer here, there isn't a clear answer. When 1 goes in, what comes out? And we don't know. Our function breaks down here. When we put in 1, we get out, well, we don't know what we get out. And so this is not h of x. We shouldn't write it like this because this is not a function. This is not a function. And the reason it is not a function is because h of 1 is not clearly defined. A lot of times we'll say the x value repeats. If we see the same x value with 2 different y values, then for that input, there is no function output because we don't know which of the outputs to go with, and a function needs to clearly give us an output for each input. So this is an example of something that is not a function, and an easy way to tell is to see if the x value repeats with a different y value produced. Okay, let's look at a different form of a function. Another form of a function is a graph. And a graph is a way of relating inputs and outputs where the inputs are how far left or right are you, and the outputs are how far up or down are you. And so each point on a graph represents an input and output. You find the input by how far you went over. So the input was 3, 1, 2, 3 over. And when 3 goes in, negative 1 comes out. And we can tell that because we went 1 down. So the positives are up and to the right. The inputs are positive when you go to the right and negative when you go to the left. And the outputs are positive when you go up and negative when you go down. This point here is called the origin, and it's 0, 0. And so this is another way of writing inputs and outputs. And we can use our same function notation we want to understand. We can write, first of all, how do we read this out loud? This is f of 3. And the way it's asking is when the input is 3, what is the output? And so when the input is 3, the output is negative 1. I want you to answer on your own, what is f of 0? F of 0 is 2. And you might notice that this point, 0, 2, crosses the y-axis. This is the y-axis of a graph. And so it has a special name. The point where a function crosses the y-axis is called the y-intercept. And f of 0 will always give you the y-intercept. Okay? We want to look at one more special point. What is f of 2? When the input is 2, what is the output? Go ahead and answer that on your own. And when the input is 2, the output is 0. And whenever the output is 0, we will be on the x-axis, and this is the x-intercept. It's possible to have more than one intercept, x-intercept, but it's where the function crosses the x-axis. It's also possible to not have an x-intercept. So with that in mind, let's go over to g of x. So here's g of x. And you'll notice this function is not connected. So the in-between values are not defined. Let's look at g of, go ahead and answer, what is g of 1? What is g of 1 here? So when the input was 1, the output was 1, and so g of 1 is 1. Go ahead and answer, what is g of 2? G of 2 is negative 2. When the input was 2, the output is negative 2. What is the y-intercept here? Well, the y-intercept is when x is 0, so when the input is 0. When the input is 0, the output is 2, and this is the y-intercept, is 0, 2, the input-output pair 0, 2. And this function might look like it has x-intercepts, but because the in-between values are not defined, this function actually has no x-intercepts. In fact, I want to ask another question. What is g of 1/2? So when the input is 1/2, what is the output? And the answer here is undefined. G is not defined at 1/2. There is no output that is clearly given by this graph. All right, let's look at our last thing, and you may notice this is h of x with a question mark above it again. And let's try to answer a question. What is h of 4? H of 4 says when the input is 4, so when the x value is 4, what is the output? And there are two different outputs given, and so h of 4 is undefined. There are two different values. There is 2 and negative 2. And so h of x is not a function. And a lot of times in Algebra 1, hopefully you're familiar with this idea of a vertical line test. You can draw a line. A vertical line is a line that is straight up and down. This is a vertical line. And if you draw a vertical line and it hits the graph twice, it will not be a function, because for that same input, there will be two different outputs. So this is still a relation. This graph still makes sense. There are still inputs and outputs, but it is not a function because there isn't just one input and output. I'd like to take a minute to show you that we can represent a function multiple ways. All of these graphs we could make tables of. So let's look at f of x. We could make a table of inputs and outputs. I could say when x was 0, y was 2. When x was 1, y was 1. When x was 2, when the input is 2, the output is 0. When the input is 3, the output is negative 1. And so tables and graphs can both represent the same function, and sometimes we'll want one rather than the other. If we go back to our previous table on the other page, here we had f of x was a table, and we can write this table as a graph. Well, some of the points we can put on the graph easily. When the input is 1, the output is 3. When the input is 2, the output is 6. We run into some trouble where, like, I don't know how I'm going to put 100, 300 on the graph and still be able to see it well. And that's why sometimes a table is more useful and sometimes a graph is more useful. We're going to want to understand both. Let's look at another form of a function. This is an equation that says f of x equals 4x plus 2. And this is a formula to find the output for each input. F of 3 means when the input is 3, what's the output? And this formula says, it gives us a formula for each input. The formula is 4 times the input plus 2. Here the input is 3, so it's 4 times 3. If I don't put anything in between here, this is a multiplication. 4 times 3 is 12. 12 plus 2 is 14. And so f of 3 is 14. That's saying when we put in 3, we get out 14. Go ahead and find what is f of 5. F of 5 you should get is 22. And you should get 22 because when x is 5, 4 times 5 is 20. And 20 plus 2 is 22. Try a couple on your own here. What is g of 4? And hopefully you can get that. Hopefully you all got g of 4 was 15. And because that's when you put in 4, g of 4, the rule is we will do 4 squared minus 1. 4 squared means 4 times 4. And 4 times 4 is 16. Minus 1 is 15. G of negative 3. Go ahead and try that as well. G of negative 3. Negative 3 squared is 9. 9 minus 1 is 8. And notice these are pairs of inputs and outputs as well. And so these could be put on a graph or onto a table. I'll go ahead and make a table for g of x here. I put in 4 and I got out 15. I put in -3 and I got out 8. I could add on new points to put in. When I put in 0, I get out -1. And so I can make a table or a graph out of an equation. The last thing I'd like to look at, though, is mostly this year we'll be dealing with equations that are functions. It is possible to define an equation that's not. The last thing we're going to look at is a verbal situation. Jose earns $40 and earns $12 per hour he works. M of h is a function giving how much money he has as a function of the number of hours he works. Here we have two variables. We have how many hours he works and how much money he has. And the money he has is a function of how much he works. And so the inputs, what it's a function of, is the independent variable. These are the inputs or independent variable. And for different numbers of hours he works, I can think about this problem and find out how much money he has. When he works 0 hours, he has the $40 he started with. If he works 1 hour, he had $40 and he earned $12 in that first hour. So he has $52, the $40 plus 12. And in fact, each hour he works, he will add on $12 more. They don't ever mention him spending any money here. And so we can, this is a specific type of function called a linear function that you should be familiar with. And we can make a graph and we could put these points onto a graph. We're gonna go ahead and stop here. I'd just like to point out that m of 2 is equal to 64 is another way of writing these points, saying that when he has worked for 2 hours, he has made $64. And hopefully you're feeling pretty good about functions to begin the year.